Welcome to Session 23, Calculator Strategy, Pacing, and Verification. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to separate modeling from calculator entry, to use passes and flags efficiently, and to match verification to error risk. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. The strongest calculator workflow leaves an auditable mathematical trail. Use this visual structure. Model is greater than entry, is greater than outchoke, is greater than triggered verification. Read every symbol and label before calculating. The first goal is to separate modeling from calculator entry. Connected to the second goal, use passes and flags efficiently. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Write the full mathematical expression. State the target and preserve its units or conditions. Step 2. Enter grouped operations with parentheses. Use a separate line so signs, factors, and labels remain visible. Step 3. Store full minus precision intermediate values. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Review units, target, restrictions, and reasonableness. Verification is part of the solution because it tests the answer from another direction. Signal 1 is entry is multi-minus step. Respond by remembering, write before typing, name the response before calculating. Signal 2 is a root or restriction appears. In that case, test candidates. The form tells you which tool fits. Signal 3 is a result has physical units. Remember, check dimension and scale. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Which review target has highest value? Restate what is requested before touching the choices. The first move is write the full mathematical expression. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. F-focused verification is more productive than indiscriminate reworking. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Store full minus precision intermediate values. The explanation supports one option without relying on its position. The mathematical conclusion is a flagged answer with an independent check available. State it with any required units, interval notation, or restrictions. The final answer is a flagged answer with an independent check available. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Repeat the calculation from the written expression or substitute backward. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Why should review not redo every easy question from scratch? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. F-focused hint. Selective review maximizes correction opportunities in limited time. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is time is better spent on flagged, high minus risk work. Explain why it works, and name the earliest line that would reveal a likely error. A central message is to separate modeling from calculator entry. Combine that with the discipline to use passes and flags efficiently. Finish by remembering to match verification to error risk. A result becomes dependable only when the method and verification are both clear. Reflection. Was the error in the model, the keystrokes, or the interpretation of output? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 12 calculator practice minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.